So in this video, we're going to talk about the number operation standard having to do with factors or factor pairs, right? Factors or factor pairs. And the first thing is to make sure you understand what the word factor means. Factor has to do with multiplication. And basically, when you have a multiplication problem, the two things that you're multiplying are the factors. So a really simple case, if we have them, let's change the color. If we have a multiplication problem like 3 times 4 equals 12. So we say that 3 and 4 are the factors and 12 is the product. So that sounds pretty boring, but it turns out that knowing how to take 12 and break it up into factors becomes really, really important for a lot of things, including working with fractions and working with algebra later on when you get to later on in 7th grade and also in 8th grade in high school. Knowing that you can break whole numbers apart into factors is critical. And when we talk about factors, we're talking about whole numbers. So not decimals or fractions. We're talking about the numbers that you're used to, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. How do you break them up? And we're specifically talking about how do we break them up into multiplication problems, not additions. We're not saying, okay, you can break 12 up into 10 plus 2. Yes, you can, but that actually isn't all that interesting for a lot of things, whereas breaking them up into things you multiply becomes really interesting. So it should be pretty obvious that 12 is 3 plus 4. 12 is also 2 times 6. 12 is also 1 times 12. And that's pretty much it. That's the only way you can break 12 up into factor pairs. This one over here is called the identity pair. It's the least interesting. It's much more interesting when you can break them up into two other numbers where the number itself is not one of them. But it is a factor pair. So 12 has 3 factor pairs, right? 3 times 4, 2 times 6, 1 times 12. And 2 of them are interesting. So 15, if we said let's factor 15, well, there's certainly 1 times 15. That's always the first one, and that's the boring one, kind of. And then there's 3 times 5, and that's it. We can't do anything else with 15. 17. Well, 17, there's only one factor pair, 1 times 17. So this is an interesting case where there are no factors other than the identity factor, 1 times 17. So we say that 17 is a prime number. Prime meaning that there are no factors for 17. So let's take an interesting one. One of my favorites is 96. So if I said to break that up into factor pairs, what would you have to do to go about that? Well, you'd have to kind of think about, is there any easy way to break this up? And one thing that's incredibly useful when you're dealing with factoring is knowing what divisibility rules are, which I know, so divisibility rules are, what are some of the easy ways to know that we can divide 96? Well, easy one is 96 is an even number, so we can divide it in 2. So 96 divided by 2, I don't know what that is off the top of my head, so I'll do a little long division. 2 into 9 goes 4 times. 4 times 2 is 8. Subtract, you get 1. 16 goes into 16 8 times. 8 times 2 is 16. Okay, well, that's kind of boring. Okay, so 2 times 48 is one of the factor pairs of 96. I'm going to erase the long division. Okay. And the other divisibility rule, which is really useful, is the divisibility rule for 3, which means if we take the 2 digits of 96, so we get 9 plus 6. 9 plus 6 is 15. 15 is divisible by 3, which means 96 is divisible by 3. If you're not familiar with the divisibility rules, you should be familiar with the divisibility rules for 2, 3, 5, 9, and 10 are the useful ones. You should go, and there's a video that you can watch that I've listed in the main document for factoring. Okay, so we know that 96 is divisible by 3, so let's see, 96 divided by 3. 3 goes into 9 3 times. 3 times 3 is 9. Subtract, you get 0. Bring down the 6. 3 goes into 6 2 times. So, 32. So the other factor pair is 3 times 32. Okay, so we have two easy ones that we could get. No, I want to erase that. Two easy ones that we can get. So let me erase this. 2 times 48 and 3 times 32. Well, notice, how can we keep going? Well, notice that 48 is also even. So we can also say, okay, 48 divided by 2 is 24. So if we multiply 2 by 2, we get 4 times 24, right? So doubling 2, halving 48. So that gives us another factor pair. And you can do it again. You can double 4, you get 8, and halve 24, you get 8 and times 12. That's also going to be 96. Actually, you can do it again because 12 is still even. So 8 times 2 is 16, and 12 divided by 2 is 6. So we can also do 16 times 6. Now, interestingly enough, we could have gotten that from this over here, 3 times 32, because if we multiply 3 by 2 and divide 32 by 2, we get 6 times 16. So that's the same thing. So we're going to cross that off because we already have it. Anything else that we can get? So we've got into 4, into 8, into 16, into 3. Looks like we're pretty much done with 96. It's a little bit hard using this technique to know that you've got all the factor pairs. Oh, and don't forget 96 times 1, although as I said, that's pretty boring and not really used for a lot of things. So we have factor pairs of 2 times 48, 4 times 24, 8 times 12, 16 times 6, 3 times 32, 96 times 1. Now sometimes it's tricky if you have some numbers like, with some weird numbers like, let's see, if we had, let's see, so let me go to another one. So 187, whoops, 187 is a little tricky. So this is kind of a pain, and I'm giving you a hard one. It's hard because the two factors are actually prime numbers. You can see if we try the divisibility rule, it's not even, so we can't do anything with that. It's not divisible by 3 because 1 plus 8 plus 7 is 16. That's not divisible by 3. It's not divisible by 5. It's not divisible by 9. It's not divisible by 10. And really all you can do is kind of try different numbers after that. So like 7, you could try 187 divided by 7. So 187 divided by 7. 7 goes into 18 2 times. 2 times 7 is 14. You get 47. 7 goes into 47 6 times. 6 times 7 is 42. And you have a remainder of 5. So that doesn't work. So 7 didn't work. We know 9 didn't work. Since it's not even, 8 doesn't work. 10 doesn't work. So we can try 11. 187 divided by 11. 11 goes into 18 one time. 1 times 11 is 11. Subtract, you get 7. Oh, and 11 goes into 77 7 times. So 11 times 17 is the only interesting factor of 187 besides 1 times 187, which is the boring one. So that was a bit of work, but that just shows you another way to factor things. Sometimes the easiest way to factor things like 187 is to use a calculator. And in fact, for very large numbers, actually factoring can be very, very difficult even for a computer.